Okay, so let's get started. My name's Mark Pulowski. I'm going to be your guide today as we go through some information about AWS and data analysis. And on my screen it says 5 tips that make data analysis easier with AWS. This presentation is really going to be about different ways of getting your data into that cloud platform so that you can work with it. And some of those things revolve around making sure that the data is cleaned, um, and right sized and things like that. So we'll be going through that. Okay, so we'll get started. So these are the things that we're going to go over. We're going to talk about how tables in AWS can be based on raw data. So you don't necessarily have to have the data hooked up to a database, or you don't have to have your analysis tools hooked up to that. If you just have raw data, comma separated value data, and it's sitting in a file, you can just upload that file and then make it available to work with. Okay. We'll talk about ingesting data automatically. So there are things inside of AWS called crawlers, glue crawlers, and they're used to read in data, and that can be done on a periodic basis. We're going to talk about how you can transform some data by using queries, and this will be in the Athena tool of AWS, and save a table, just say something that's a very large table as a smaller table, by creating a query that reduces the number of columns or the number of rows, and then saving it easily as a physical table. And then we'll take a look at saving data in columnar format. So you might have heard of the Parquet format, and there's a couple of other columnar formats which make querying the data much more easy when it comes to the amount of time that you're going to be spending, because the columnar format allows for querying with much less data being pulled from the data source. And then cleaning up data. AWS has tools in the Glue Studio to make it easy to do some of the basic data cleanup that you have to do, like renaming columns, dropping columns, changing the types of columns and things like that. So we'll show you how that tool works. So the first thing we'll do is each one of these areas has a slide where we'll just kind of go over why we're talking about that particular area. So the first one is tables based on raw data. So it starts off with the fact that the queries and transformation can be done in the AWS tools without having to move the data out of a traditional database. So now it is possible to also do queries and transformations with data when you're connected to a database. Okay, so if you already have the data in a database, that's fine. If the data came from a mainframe system or some other system that outputs flat files, you can use those. That's kind of what we're talking about here. Okay, the raw data just needs to be uploaded to S3, which is the cloud area for files in AWS. You add metadata to it so that the query engine can understand which columns are named what their types are, things like that. So that's added onto the raw data. In fact, the raw data sits by itself, and when you add these things on, you're actually doing it by creating tables, and so we'll explain how that works. Then you can do, once the data's in there, you can do whatever transformation you want in Glue Studio, and you can run queries in Athena, and then you can output visualizations in QuickSight. So all those things are available to you once you've got the data in. So let's take a look at how we could set this up. We'll start off with uploading some data to a bucket. So let's go here. So I've got a couple of these AWS consoles running. Let me see if I can make this a little bit easier to read for you guys. Okay. Okay, so we have a bunch of buckets. If you've worked with AWS at all, you know that you usually have extra buckets because it requires certain buckets, which are basically uh, like file folders um, that where the data is kept up in the cloud. And a lot of the tools create their own folders for certain things. So you'll see some of these calling Athena query results, AWS glue assets. All those are used for those specific tools. The two buckets that we've created for today would be the raw data bucket, okay, where we're going to have a couple of what are now empty folders. We'll use them as we go through the demonstration today. But the first thing we're going to do is just go to this folder called avocados. And from that, you can probably guess that the data set we're using is the avocados data set. So before we upload it, let's take a look at it. Let me find it for you and then bring it up in a text editor. And then we'll see what it looks like before it gets up into AWS. Okay, let's see. I'm just looking through my directories. Give me a moment. Okay, so here it is, and I'll bring it on the screen. Okay, so here's our file, and I'm just opening it up in a text editor. This is of size about 2 megabytes, 1.9 megs. And it's information about the sales of different sizes of avocados to different regions on different years. Okay, so you have date, you have average price of these things, the number of units sold, whether it was a conventional or organic product, what the year was, what the region was. Okay, so you have a bunch of this information. This is what we're going to upload. So we're going to take this file avocados.csv and upload it. So let's do that. We'll do that by clicking in this bucket here, adding files, and let's find the webinar. Lab files, create table, avocados. Okay. Okay, so we do that and we click upload. So we're introducing the data into the system now. This is a 2 megabyte file. Most of your files for data analysis are going to be much larger. Okay, but it's a lot easier to do a demo with a smaller file of this nature. So one of the things we can do once it's in here is we can click on the file, so it's here, and see some information about it. Okay, kinds of information about where it's going to be located in the cloud system. And one of the things you can do here, if you're curious, is you can query the file even before you've introduced it to the other tools, right? You can just go here and have it do like a quick SQL type statement on it. So select star from S3 object. So it's from whatever this file is. We can run the query. And we see that we bring back the data, with the first row being the names of the fields, so columns. Okay. So what we want to do is take that. So we've uploaded that, and we want to create the metadata that's needed by the tools in AWS to read that table, because it's just comma separated values. If you don't have metadata for it, it has to kind of read through everything to figure out what's happening. So you don't want it to read through the full file each time, just if you want to, select a couple of rows. So the way we do this is we go into Athena, and we see that we've got a data catalog and a database set up. Now the database here is just it's a container for what are called tables in Athena. Tables in Athena are metadata that point to raw data files. So it's different. Athena itself is not a database, but it has this thing called a database, which holds these definitions so that you can refer to them within the tool. So what you can do is you can do a create table, which again is not going to create a table like it does in a database, but it's going to create the metadata that's going to allow you to access some raw data. So we click create table, we click from an S3 bucket data, okay? And then we're going to need to go into here. We don't want to create a new database. We'll use the default one throughout the demo today. And the table name, the new table that we want, we'll call this raw avocados. Okay, and we're going to tell it where we want to take this data from. And this is going to be from the bucket and folder that we just uploaded it to, right? So you notice we're not telling it that we want to point to the file that we uploaded. We're pointing to the directory that that file is in. Because one of the things about this setup with AWS is that when you're working with data, it assumes that you could have one or more data files, all of the same structure, each one having unique data in it. So it would go in there and read all of the files that it finds in that directory, including the one that we put in. Okay. So we say next, we're going to tell it that we know it's a comma separated value file. But then we have to put in the column names. And to make this a little bit easier, I've gone and done this ahead of time. We can add these in bulk. It needs to know the names of the columns. Okay. Now this is just one way to do it. We'll add that there. And it adds the ID field is an integer, the date is a string, etc. Goes through all of the things that I added, which represent the columns in the file. This way of creating the table requires you to know that ahead of time. But there are other ways, including when we go and use the glue crawlers, that it will infer that information from the file itself. Okay, so there are other ways to do that. Okay, so we'll click on next. Okay, we don't want to add partitions. We'll just leave it the way it is. We say create table. Okay, so this is what it did. It created this create table SQL statement, okay, which is specific to the tool. And then it created this here, the raw avocados. Let me get rid of this one. We don't need this one right now. Delete that table. Okay, so we should be able to look at this, and you can just click on the little 3-dot menu and choose preview table. It'll pop up a SQL statement, and the data will be down here. Okay, so that's kind of nice. One thing that you notice, and this is an anomaly or like a bug in AWS, it seems to, when you do it in this particular way, it forgets to ignore the first line of data. So the first line of data becomes a line that has some of the column names in it, which you don't really want. But that's easy enough to fix because we can go back to this table create statement that it gave us, and we just need to add a something down here, which tells it that we don't want to see the headers. So let's do that. But before we run that, we'll delete the table. Now remember, deleting the table here is only deleting the metadata. Okay, the actual file, the CSV file that we put in, has not been touched, right, by this delete. And now I'm going to go back to this modified version of the create table, okay, and run it. And you'll notice here's our location, our avocados directory. So we run this query this time, it should create the table again. And let's make sure it took it. Okay, so there it is. And this time when we run preview table, we should notice that we don't have the column headings in the data itself. So the first line of data is actually data. Okay, so this is data that comes from our table, and we can now go in and do any kind of SQL queries that we would like to, okay, on this raw data as if it was a table in a database. Now, one thing we should notice here, because this will come up later, if I just do a select star from default, raw avocado, so it's taking it from that file, an important piece of data shows up down here. The amount of data scanned, okay? This is part of how AWS charges you. It's by the amount of data that gets scanned for each operation. The more data scanned, the more they charge. Now, for 1.9 megabytes, it's virtually nothing. But if we had, a couple gigabyte file or terabyte file, then it would make a difference. Whether it was 2 terabytes or 1 terabyte would change, make a big difference in the amount of cost that was involved in running that particular query. Okay, so for now, we'll just see that the largest amount of data is the full file. Remember, I said the file itself was almost 2 megabytes in size. So when we run a query that shows all the data, it has to scan the whole table. Okay. And even if I do this, if I do count of star, so now this should only bring back one piece of data, which is how many columns there are, or how many rows. It still has to scan the whole file, okay? So if you have a large file to begin with, even though you're only using part of the data, you're not getting any of the benefits of using just part of the data because it has to scan the whole table. So some of the things that we'll take a look at will come down to figuring out how to change that, okay? So that's, so our data is raw data, and we've hooked up our table by putting the metadata in, and now we can work with it. So that was the first thing we wanted to take a look at. Okay, tables based on raw data. It's really easy to upload something and add table definition to it. The next thing, we're going to talk about a different way for you to get the data in there besides putting in your own list of the name of the column and the type and the name column, the type, without having to create that. Okay. And there's more than one thing that's going to happen here. But to back up a second, what we're going to be using is something called the AWS Glue, which is a part of AWS, a crawler. Okay, a crawler is a type of a software that will go and create tables from raw data automatically. And you can set these things up to run when you want to, which means on demand, or you can set them up to run every 5 minutes or every hour or every day or every week, once a week, to pull in new data that's being generated by the organization, right? So if you have all your sales regions are reporting on a Thursday, you can tell this crawler that every day on a Friday morning sometime, you could tell it, run all of these crawlers to pull all the new data in. Okay. So we'll take a look at this glue capability. Okay, so we know we have that one data file. I'm just going to close these out. So when we get back to this, we don't get confused by the extra things that are already there. Okay. Okay, so you might be wondering, I deleted this crawled raw data avocados before, but it came back. So how does that happen? Why did that happen? Well, let's go to our AWS Glue console and take a look and see that we have this test crawler that I had created before the session today, which crawls every 5 minutes. So even though I delete the table, every 5 minutes it wakes up and it looks at the data again and it creates the table again. So as you can see, last runtime was 50 seconds. It took 50 seconds to run. And I don't want that to run anymore, so I'm going to delete that. Delete that crawler. Okay. But now we have a couple other crawlers that we could create from scratch, but it's just as easy to do an edit on them and see all the same information. Okay, so what we want to do is crawl that raw data. So let's take a look at that and edit it. This is within AWS Glue area, and it's it's kind of like a wizard for creating crawlers. So you create a name for it. You try to put as much information in here as possible so that you can identify the crawler later on, okay? Even when you have other crawlers that are similar. So we have a name for it. We're taking the data from S3, okay? And we want it to crawl all folders. Now, here's an option that lets you change the way that you put data into the system. Here it's saying you can have it crawl all the folders underneath a root folder that you give it, and then it always crawls all those folders. Or if you set it up so that whenever you inject new data, you upload new data, you put it into a new folder, okay? Then this is going to be useful, the second one. You can have it crawl new folders only. So if there were 5 folders the last time the crawler ran, and then a new folder was created after that, then it would only then crawl the new folder. It would leave the other ones alone. So it really depends on how your data is getting generated, how you're uploading the data, but there's some flexibility here as to how you do that. Okay. We had a data store. The data store we're going to look at is S3, which is the buckets of data data files. But there's these other options too. All right. If you have a JDBC database, you want to pull data from there and have it create tables within within Athena, so that you could use Athena to do work on it, or use Glue to do work on it. Then you could do it through JDBC. If you have a DynamoDB, which is one of the Amazon products, you could do that, or the DocumentDB, or a MongoDB instance. Okay. So there's a lot of different ways that you can pull data in and create a table. Okay. This connection you don't need because we're just going against the current cloud folder or bucket. Okay. But we do have to go down here and tell it where we want it to look. So we're telling it to look in the avocados directory of the raw data bucket. Okay, and that's where we uploaded the file. Okay, if we had uploaded multiple files, it would go in when it does its crawling, and it would read through all the files and use all of them when it creates its table definition. Okay, we don't want another data store. Here you have to choose. This is in this is how you set up the permissions. The IAM roles are the permissions to be able to use certain parts of the of AWS. So here you're just telling it that you want to use an existing role that you have called the Glue service role default. So it has permissions that are needed to run the Glue tool. Right? And then we just say we want it to run on demand. If we don't want to run on demand, we can say we want it to run every hour or every day, or we can choose certain days of the week, and have it run weekly, monthly, or custom. And if you do custom, then you can change it to things like every 5 minutes or however you want. But for what we're doing, it makes sense to do run on demand, which means it's not just going to be waking up and creating new tables unless we tell it to. Okay. And then we're going to put this into this database. And remember, the database listed here as default is just a container, right? And we're going to tell it to give the table a prefix of crawled raw data. Now, this is optional. You don't have to do it, but I find it makes it easier for me to track what's being created by what. Because when you have a bunch of crawlers and you have somebody else who's coming in and creating tables manually through Athena, and everybody's using the same name, it gets hard to track everything. So this will be the prefix for the table that's created using this crawler. Okay. So here's all the information. You can kind of scan it if you want. What we're trying to do is bring in that table data, and we can create a new table definition. Okay. So it ran, Oh no, we created it. Well, now we need to run it. So crawl raw data. Click on that and choose run crawler. Now, when you do run crawler, that's a process, right? It's going to spin up some resources or find some resources to run this process on. Okay, so it takes a little bit of time to do this, and then it runs. It usually doesn't take, in our case, more than a minute to run. But if you have a much larger data set, it could take longer. But this is what you see here. And when it's done, you'll be able to refresh the page, and you'll see information about how long it took the last time it ran. Okay, and then we'll be able to go into Athena and find it. So let's take a look in there. I don't think it's in there yet. Crawled raw data. Okay, let's see. This is probably the last one from that other one. So let's delete this real quick. It should create a new one as it's running now. Okay. And if it didn't, we'll run it again. Okay, it actually had run pretty quick. So let's do it again after it stops. Yeah, it'll take a little bit for it to wind down the instance that it brought up. And once it does, we'll be able to choose run crawler again. Now you'll also be able to see if there are any errors during the run. When it's finished under logs, you'll be able to go to the logs and it'll tell you it didn't run or it didn't finish for this reason. Okay, we're gonna have to come back to that in a minute. Yeah, so what we want to do is we want to show the results of that having crawled the data. Okay, it's just going to take a little while until this is ready, because it looks like it has gotten stuck. Okay, so let's just create a new one. Crawl raw avocados data. So it won't be bad to have a little repetition here. And data, that's the same. S3. Let me see if I still have that. No. Let's bring it back from here. Include path is going to be the raw data bucket, avocados, which is where we put the file. Okay, let's see, sample size. Next. No. Choose an existing role. Run on demand. And we're going to give it a different prefix this time. It's going to be crawl raw. I think it was different before. Crawl raw, and then next. Okay, so we should be able to run this. Okay, so that's this one here. Now, while that's running, you can take a look at the logs for the other one. So you see what that looks like. And let's see, so here the log tells you a little bit about what's going on. Started the crawl, okay, writing results of the database, update database, finish writing. So if there were any problems, you would see it here. Let's go to Athena and see whether it has that table. No, I was a little too quick to try to clean things up before, so we'll just wait for this one to be done. But while we're waiting for that, I want to go take a look at the next thing. So this was about running the crawler. When we're done running that, and we can actually take a look at the data and see that we can work with it in Athena because it's now been created as a table within the system. Okay. After that, we had wanted to go and take a look at saving queries as a physical table. So you have this, in this case, 1.9 megabytes, or maybe you have a terabyte of data in your file. But it might have a lot of columns that are not strictly required, or rows that are not strictly required. So you can create a query to narrow that down, but running that query is always going to take that same amount of data. It's going to look through the whole table. So what you want to do is you want to not just run that, but you want it to run and save it as a table. Okay, so now you'll have a smaller table that represents most of the data that you want to run your reports on, and then you'll be able to run all of your reports over that as opposed to the larger file. So that's the idea behind this next piece that we'll look at, saving queries as physical tables. Let's go back here and see if that's stopping. Let's see whether we have the data now. Okay. So here, crawl raw avocados. You see it's brought it in. And this time it's assigned the different types to the different items here. And it's actually taken the names and it's done a little bit of work on them too, because the names had some uppercase characters to them. So let's see if we do preview table. Okay, and then we see that the data is in there. Okay. So in this case, we didn't have to tell it for every single column what the type was or give it the name of it. It actually inferred that from the file, which is one of the advantages to using a crawler to create your table. Okay, and here's our raw table that we created by hand by setting up the types and the names of the fields by hand. And you notice they differ slightly, right? So this is these are floats here. Here they use double precision numbers. Okay. Okay. So one, you can set that up to automatically figure out what data is in the table, create the structure for it, and you can do it on a schedule. Okay. So that you can have it bring in new data periodically without you having to like go in every Friday morning and click on a bunch of crawlers in order to get them to run. Okay. Okay. With that being said, we want to take a look now at this idea of saving a query as a physical table. Okay, so that it uses less resources when it runs. And close all these guys out. I'm just closing out the queries. It doesn't get rid of the tables or anything. Okay, they're still there. Okay, so we saw that if we did on this raw avocados table, if we did a preview, that it's going to look at the whole file. Right? Let me do that without the limit. And it's going to be 1.9 megabytes. Okay. But the other thing we'll notice is that if we look down here, the table actually has a type column. Okay. So what are the types? We can do select distinct type. Okay, and distinct type should just tell us the different types that are in there. Okay, so we have conventional and organic. Those are the only two values that are in the type column. Okay. If we do a select, let's see, this one here, select star from that where type equals organic, Okay, we see that it still has to run through the whole file. Okay, but now we've got less items in here. In fact, what I can tell you is that when you run this, if you did a count, you'd be able to tell just how many there are. And here we see that there's 9,123 of these items. And the other one, if we change this from organic to what was it, conventional, then we'll see the other one's close. It's 9,000. What doesn't it like here? Conventional. Run. Hey, this is 9,126. So it's about evenly split. But whenever we use this type equals conventional or type equals organic, it's still reading the whole file, okay, which is inefficient. Not so bad when you have 2 megabytes, but when you have a terabyte, this could be a big difference in the amount of time and the amount of money that's involved with running the query. Okay, so what we want to do is create a table, and we'll do it like this: select star from default where this is equal to organic. Okay, and now what we can do is we can run it, take a look at it. Okay, and then we can do a create. Click this create button and create table from query. And this is going to create a physical table from the query. Okay, and let's see, it's default, and let's say raw avocados, because it's coming from the raw avocados file. Organic, just the organic ones. That'll be the name of our table. Okay. Output location, and now we're going to put this in a different location. Let's see. Oh no, we can put it in the same place. I already have set up. Okay, we had set up a couple of directories, one of which was this raw avocados organic directory. I'm going to make it CSV file for now, but let's just take a look at that. We should see under our S3 and our buckets in our raw data bucket, we have this raw avocados organic. So, and there's nothing in it right now. Okay. So let's go back to here. Okay. So I'm going to tell it I want it to save it out in comma separated value format. It looks like this, and then we can click create. Okay, so it created this raw avocados organic, and now the question will be, if we run a query on that, will it use up as much data? Will the data scanned will be more or less than it was for the full table? Okay, we'll take off the limit here so that it looks through the whole file. And you notice now that the data scanned is just 267K. Okay, well, that's a lot less than 1.9 megabytes. So let's take a look at how that happened, right? We should be able to go back to the bucket. This is the raw avocados bucket, and we'll see that there's a file in here. And I have to refresh it to show that. Okay, here's the file, and the file is actually 267K. Okay, so when you're querying against this table, the most it can ever draw as far as the data is this 267K. And that's because in addition to making it comma separated value, it also made it of type zip. So it did a comma separated value and zipped the file so that whenever you do file transfers or when you run queries, it's going to be less, right? It's going to be just the amount of that file. Okay. So that's where we're going to be getting a savings. Here's one way to look at it, right, from this physical table that we created. Or if we went back to here, this is the same query, only using the full table that we originally loaded. Okay, and it's 1.9 megabytes. Okay, so let's see what else we have coming up. So that was the advantages of saving it, using this tool to save it as a new physical file. And now you can keep running your your organic queries off of that. And let's take a look at what we have next. Okay, we have saving data in columnar format. Okay, so another way for you to save time and money is to save the data in a different format that's more efficient for different types of queries. Okay, so what it does is it separates out the data. Instead of the data being saved row by row, it shreds all of the records and it saves them by column, meaning all of the type column is saved in one place. All of the date column is saved in one place, you know, things like that. And then when you run a query, if the query only uses 3 columns, then it can ignore all the other column data, okay? So it doesn't have to retrieve as much data, okay? So less data needs to be transferred when columns that don't show up in a query are skipped, okay? So the format we're going to use here is the Apache Parquet format. Okay, so it's just going to be a similar process to what we saw before. Okay, where we took this original table, the raw avocados table, and we want to keep all of the data in the table this time. But we're going to save it as, or create table from query. And this time the table name is going to be called avocados columnar, because that helps me remember that it's column formatted data. Okay, the output location, we're going to put this into another directory that was created. You might have seen as we were looking at S3, the avocados columnar directory, which is currently empty. So if we look back here in the raw data bucket, we have avocados columnar, but there's no data in it yet. Okay, and this time instead of choosing comma separated value, we're going to choose Parquet, which is the Apache Parquet format, which is a standard, well-used columnar format. Okay. And let's see. Okay, so click Create. Okay, so now we've had this avocados columnar here. Let's close some of these guys down. Okay, and we're just going to do a regular preview query here, preview table. Okay, and this time, okay, well, let's get rid of the limit. Okay, because that limits it to just 10 rows. We do the whole thing. So even when we're doing the standard query, select star from this one, it's still like 1/4 the size, okay? Because in addition to putting things into column formats, it also does compression, okay? So that's one thing. And this is then going to be the same query as if we did this here under raw avocados. So if we did that, and this one again, raw avocados, should come out at 1.9 megs. Okay, so you've already got a savings just from the compression that's being used. But what about if you went in here and said, we just want to do a query that shows the ID, the date, and then let's see what else we have here to use. Date, average, let's say total volume. And region. Yeah, so we just pick some of the columns. Run that query. We see this query is dramatically smaller because it's only using a few columns. It's only 68K that is being used to retrieve it. Okay. If you ran the same thing On the original raw table, it would be 1.9 megabytes. Okay, so you can start to see that it's not just half. I mean, some of these can be dramatically smaller. And if I did this, okay, if I did count of star from this, now this is just going to give me the number of records in the table. Okay, you notice that the amount of data scanned is so small that it's reported as 0 kilobytes. Okay, so, and of course, if we did it here with the original table, it would have been 1.9 megabytes. Okay, so these are some of the tools that you can use to convert things and allow you to run queries quicker and with less cost when you're doing your data analysis. Okay, and let's take a look at just one other thing. Okay, which is this last one here, cleaning up your data. Okay, so there's a lot of reasons why you might want to clean up the data. Okay, and AWS has some tools. Let's take a look at one of them that I've set up that we can take a look at, which is our Glue Studio. So if you go to Glue Console, okay, you can go down here and there is something called Glue Studio. Okay, and under Glue Studio there are jobs. Okay, and you can create a job. In this case, I had created one earlier called Transform Avocados. Okay. Okay. And how this works is you can put these different operations in a row and connect them with these with the arrows. Okay, so you start off in a data bucket. Okay, so I clicked on the first one. You can see that we're getting our data out of that avocados bucket from the avocados CSV file. Okay, so that's going to be the source of the data. And now let me make this a little bit smaller so we can see this better. Okay. So we're going to start with the data from there, and it automatically figures out what the types of all the fields are in the data and shows them here, because that's what's going to be presented to the next one of these items in this transformation. So the next thing we have is transformation select fields. Okay, so in this particular transformation, and the way these are created is you go up to transform here and you just choose one of the different types of transformations. Okay, some of them are very straightforward, selecting fields, dropping fields, renaming fields. Okay, and then you've got things like here, Spark SQL. You can run SQL commands through a Spark system on that. Okay, so there's a whole bunch of different ways that you can condition the data. So I chose some of the easier ones, right? So selecting fields, it shows that the data is coming from this S3 bucket. That's the source. Okay, it's going to transform it like this. These fields are going to be chosen, okay, and the ones that are unchecked will not be chosen. So you'll see the output schema only includes the ones that we chose. Okay. Next thing we can do is go down to here. So it goes from there in this form, and now it goes to apply mapping. And in mapping, what you can do is you can change the names of the columns. So here I've changed the name to be all lowercase, and I've changed the name of average price to be price per item, and the total volume to be item count. Okay, and if you want, you can change the data types as long as it's reasonable, right? You know, you can't change certain types into other types, but you know, certain types of numbers you can change into other types of numbers. Okay. And so the output schema here is going to look like what we just transformed it to: ID long, price per item count, etc. And that's what's going to be saved when we get down to here. It's going to be saved in an S3 bucket in CSV format, but you could choose the other formats if you want. Okay, we're going to tell it what location, and we're going to save it into the clean data bucket. So we're assuming now that we're taking from the raw data bucket, conditioning it, and putting it into a different bucket. So if we look at the clean bucket, we should see that that is clean. There should be nothing in it right now. The clean data bucket, avocados, is empty. Okay, so that's what we're going to change. Okay, so, and then we're doing this thing here. So if you've used this tool before, you know that it will try to add the data into that bucket as raw data, and then it'll try to automatically add it to the data catalog. And there's some glitches with that. So we say do not update the data catalog. We'll do that manually afterwards. So we can run this. Okay, so we'll click on run. Starts a job. Just like a crawler job, it takes a little while to start up. And you can take a look here under runs, okay, to see previous runs, and then to see the current run as soon as it gets started. You can also go to monitoring over here, okay, and monitoring should show at some point that we're running one. So it hasn't gotten to the point where it's fully up and running, otherwise we would see that here. Okay. Okay. So just to, as we're running out of time, hopefully this will finish. We can show you that. So we have one running now. Okay, you see that listed here. Shouldn't take long to run. And what's going to happen? Well, it's going to put some data in this clean data bucket, okay, which we can then ingest. Let's see, avocados, let's do that there. Okay, so it hasn't finished yet. Otherwise, the data would be in here. And then what we would do is we would go to Glue. Let's see if we can do this over here. We want to just do the Glue service. AWS Glue. And we would run a crawler to bring it in as a table. So we'd find a crawler that was created before, crawl transformed, and that's what we would run after we ran this piece, and it would create the table in Athena where we could use it. Okay, so let's just go back and talk about what we had gone over today. So there's a lot of different ways you can bring data into the system. You can bring data in as raw data. You can bring it in if you have it in another database. You can connect to that and bring it in. Once you've brought the data in as raw data, you can create tables with it by adding metadata to it. Okay, and you can do that manually or with a crawler. You can save a query then. You can run queries in Athena on that data now that you've created the tables for them. And you can save them as new physical tables, so you can kind of make them smaller, so that just say you have to run 50 different reports on that set of data. Since you've made the data smaller, chances are those reports are going to take less time and cost less to produce. Okay? Another way to save time and money when you're doing these types of transformations is to put the data in columnar format, which can be done automatically, as you saw when we save something as a physical table. And you can also just clean up the data using that tool that I just showed you. As an hour is never really enough to get through everything we want to, but thank you for being here. We're WebAge Solutions, and we have a lot of different trainings for AWS and for a lot of other technologies. So, it's worth taking a look up at the site, webagesolutions.com, to find out more about us and the courses that we have. Thanks again for attending. I hope that you have good luck with AWS and your cloud data.